Okay, thank you, Christiana. I appreciate your hard work. Here we are, guys. We're back again. We're still doing Physics 122. We did finish last time topics 20, 21, 22, and problems associated with it. Let's finish this out and do topics 23, 24, 25, these 9 problems I'd like to do for you guys and see how we feel about it, see how we can do. And we'll kind of take it from there, you guys. All right, so let's go to topic 23. And for topic 23, we have 11, 14, 19. So let's have a look here. For problem number 11, topic 23, a 2 centimeter high object. A 2 centimeter high object is placed 3 centimeters in front of a concave mirror. If the image is 5 centimeters high and virtual, what is the focal length of the mirror? Okay. I'd done this with my other class, the calc-based class, and just want to kind of tell you guys a few things. Basically, how we're doing this whole thing, there's a few like basics that always kind of show up. They use different notation in different books, which is sometimes a little bit challenging, I guess you could say. But you're going to find with lenses and with mirrors, many of the same equations, or many of the same, I guess many of the same concepts, and certainly some of the same equations hold, whether you're talking about mirrors or lenses. Sometimes they actually hold, they hold quite often. So, I mean, it's a little less stuff to worry about when we talk about something like this. As we are saying this, we will look at, magnification. And again, the challenge here is different books and different authors use different symbolism. They use H prime for the image height. They use H for the object height. And then they use Q for the image distance, and they use P for the object distance. So I don't know. To me, there's perhaps some better, easier, more intuitive notation out there. But the book has done what it has done. It is a great book, and we're going to work with it. So basically, what we're talking about is, H prime is image height. H is object height. Q is image distance. It's not really that intuitive. I mean, I guess there's symbolism that's a little more intuitive. You put an O for object and I for image, and that's what I've seen in different places. Unfortunately, we're not seeing that here. But you can use whatever notation you want, just get the right answer at the end. Q is image distance. And again, guys, be looking at the book on this. I can't go cover to cover on this thing with the book. Look at the book, look at the summary that's in the back of each chapter, and be reading the book as best you can, and we can do this, guys. We're kind of limited in the time that we have. I mean, I got the person here kind enough to be helping me. Person kind enough here to be helping me is behind a mask so they can protect me. And and so it's not. This is not ideal. Nobody's fault, guys. It's just not ideal. Q is image distance. P is object distance, and that's about it. And we say a bunch of stuff and things you want to look out for and everything like this. For the focal length of a mirror, talk about its radius of curvature. Radius of curvature is r over 2. The radius of curvature is r, so r over 2 is going to be the focal length. There's mathematics you can do to kind of get all that under control. All right, there's a lot here. I mean, we'll use the equations as we need to use them. We can't write them all down. I don't know how efficient that would be honest with you. So, but we'll talk. I mean, we're the whole process here, how it's going to go. Well, again, number 11, a 2 centimeter high object is placed 3 centimeters in front of a concave mirror. If the image is 5 centimeters high and virtual, what is the focal length of the mirror. It's that simple. So for this right here, again, all of these problems, guys, I have tried to do at least relatively meticulously in the notes that you have. So always, if you're not going to follow me doing this thing more or less live as I'm being taped, or not able to do so, but don't lose a tremendous amount of sleep on it. Let's just get it right. So the object's in front of the mirror, something's going on. Let's see how this happens. I mean, there's a drawing I guess you could make here. So let's see what we have. Here's a concave mirror, so you're looking that way. The object is right here. We'll call it O for object. The focal length is going to be right here. We don't necessarily know what that is. The radius of curvature is out here. These are all distances here. Let's see some of the stuff that goes on here. We looked at this thing, and let's say right from the object height right here, there is going to be the rays come off from the object here. That's visible, isn't it? That should be visible right there. Okay. And then it comes back, goes right through the focal point. Goes right through the focal point. Then some other stuff you can do here. I mean, you could say, draw a line like this, and then draw a line that way, straight out that way, then draw it out this way. This guy, draw him out this way. There's just never a good way to draw this stuff sometimes, guys. And here's your image. This guy going out this way, this guy going out this way, and they meet up. There and there. Given what's going on right here. Let's see here. I think I drew everything I wanted to draw. So here it is. Here's the image height. It's going to be H prime. Here's the object height. That's going to be H. And got a radius of curvature. We got everything else. I think we got everything up here, guys, that we need. Okay, we got everything written down. Like I said, I wrote it down as much as I could. You'll see it in the notes when you look at it. Magnification is greater, it's going to be greater than 0. So because it's a concave mirror, I think we're talking about. Let's see how they actually said that actually. It's that high, that virtual. Okay, we got the whole process here. So what we can do here, guys, is in and of itself, maybe it's not going to make it m being greater than 0, but in this particular case, m is going to be greater than 0. Let's take what they gave to us. We got h prime over h, which is, didn't they say it was 5 centimeters high over 2 centimeters? That's 2.5. That's the magnification factor. Of course, all this is equal to this, negative p over q. Again, I do like the way, though I'm not a great fan. In fact, please, no, strike that. Let me write that differently. Negative q over p. Q is virtual, p is real. I prefer di, do, to be honest with you. Distance for image, distance for image, and distance for object. But this is the image distance, this is the object distance. That's also going to be this. I mean, it's all, we said, we figured this out, it's going to be that. So let's do some of the mathematics that we can do here. Let me multiply by -1 on each side and also multiply by p on each side. And the image distance will be 2.5, rather -2.5 times p. So you've got that. What does that mean? Well, they told us what the object distance was. It was 3 centimeters away. That was the object distance. It was 3 centimeters away. So Q is going to be -2.5 times 3 centimeter object distance. So the image distance is going to be 3 times that distance, but associated with a negative location, which is on the negative location is on the other side of the mirror. And again, they give more specifics of this in the book itself, guys. Kind of limited to how much time I got when I do this. I want to get this through to you. You got Q is equal to this. You got P, as we already said, is 3 centimeters. So we got all this looking at us. And from here, I think we got the hardest part of the problem done, to be honest with you. Once you bring it to here, you're going to take advantage of that. So, a lot of ways to go here, guys. I went a little more symbolic. You do whatever you want to get this right. You know, you do whatever you need to do to make this happen. 1 over F remember that. Okay. Remember that and solve for F and then figure out what you're going to do. In the end, I think they're asking for, at the end of all this, they're asking for the radius of curvature. The radius of curvature can be obtained from here. I mean, if we know that F is R over 2, that implies that R is 2F. Not saying anything too profound. We're going to have R in a second. Just figure it out right here. This is 1 over F. One over P is, well, it's, you know, it's your call on this one, guys. What I've done, the way I did it, you know, you're basically what you're going to do here, guys, is you're trying to find F. Once you find what F is, you put it right here because you solved F equals R over 2. You solve for F equals R over 2. You solve for R. So you multiply by 2 on each side. R equals 2F. You put F right here, you double it, you get what R is. Easy as that. So let's find F. I already know what P is, it's 3. I already know what Q is, it's -7.5. What's F? The rest is just whatever mathematics you want to do to solve for, to get that done at that point. So what we can do is, if I could get enough chalk here, you guys. You've got this right here. What are you going to do? Let's be very symbolic about the whole thing. Multiply by Q over Q here. Multiply by P over P. You know, multiply by a special one called Q over Q right here. Multiply by a special one called P over P right here. And you end up getting Q over PQ plus P over PQ. You get this. This is going to be Q plus P over PQ. If these two are equal, their reciprocals are equal. And that's basically the move I've been making on a lot of this stuff. I keep it symbolic and go for it. Flip them upside down, and this should get you there. This should get you there just fine. Q plus P or P plus Q, that don't really matter much. That's the whole process. So let's find the focal length. They didn't ask us what the focal length was, but they did ask us the radius of curvature, so you got to get it under control. You got three, these are all centimeters, so in the end it's going to be centimeters the answer. It's going to be, here's going to be centimeters times centimeters, centimeters plus centimeters, just centimeters, centimeters times centimeters is centimeters squared. Centimeters squared divided by centimeters is going to be in centimeters. That's not going to be, so we're not worried about that at all. We got 3 times negative 7.5 over 3 plus negative 7.5. That's all it is. That's all that it is. Do the multiplication here. You got negative, you know, there's a whole bunch you can do, I guess. Let's just multiply it here and figure out where we are. This should be negative 22.5. Add these two. Looks pretty good. I mean, looks like straight out 5 it's going to come out to. We actually do it. I mean, at the end of the day, that's 5 centimeters. Yeah, looks about right to me. So you go here. 2 times the 5 centimeters. Well, without further ado, R is 10 centimeters. So that's number 11 for us, guys. That's, you know, that's kind of the process. So let's keep along that line of reasoning and see what we can do related to this. So for 14, let's see what we got. For number 14, a 1.8 meter tall person stands 9 meters in front of a large concave spherical mirror having a radius of curvature of 5 meters. Determine A, B, C, D, E. There's a lot here. Here we go. A, determine the mirror's focal length. B, the image distance. C, the magnification. D, is the image real or virtual? E, is the image upright or inverted? There's a lot there. Pretty good stuff. Pretty classic problem. Let's take a look at it. Let's take a look at it. Let's get it right. So we're going to get asked a bunch of stuff here. Let's work for it. Let's work for it. You saw some of what goes on here. You saw the drawing. Got some of these basics right here. Here they gave us the radius of curvature. If they gave us the radius of curvature, take the radius of curvature, divide by 2, and you'll get the focal length. So they made things pretty easy in that regard. Let's see what we got. Okay, so for 14, you know, it's pretty straightforward stuff. They want the focal length. That should go pretty smoothly. It said the radius of curvature was 5 meters. 5 meters divided by 2 is 2.5 meters for that problem. And that's for the focal length. Pretty straightforward stuff. They are asking, in addition to that, they're asking for the image distance based on things that have already been given to us. So let's have a look here. They're telling us that the object distance is 9 meters away from the mirror. Object distance 9 meters away from the mirror. Radius of curvature 5 meters. Focal length, therefore, is 2.5 meters. We'd like to know the image distance. Tell you what, for the image distance, we're going to go here again. Pretty bread and butter in a lot of these problems, you guys. You go here, watch what's happening, and I think we're going to be okay. 1 over f equals 1 over q plus 1 over p. Very strong, very basic stuff. And that's what's going to get us there to where we need to go. So let's see here. I'm going to take this, I'm going to try to solve for the image distance. How about you subtract 1 over p on each side? I I gotta find the image distance, which is Q. Again, I do not like the symbolism, but let's get used to it. I got it written over there on the far left. So we got 1 over Q, we got 1 over F, minus 1 over P. Let's solve for Q. Okay, there's a lot of ways you can do it. I'll tell you what, let's try to get some common ground here. We'll leave this guy as is. This is not the only way to do this, guys. I wish I had more time with you guys, you know that. Let me multiply this guy right here, just this guy right here, with a special one called P over P. This guy right here, let me multiply with a special one called F over F. What you're gonna get is, you're gonna get P over PF. Here, you're gonna get F over PF. And I think you know where I'm going. I'm preferring to go, you know me, I prefer to go as non-numeric symbolic. I prefer to go in a way that is non-numeric symbolically as is possible. I just think it's easier. I think you get more insight out of it if you're doing things without putting numbers in there until the very end. So the numbers themselves are symbolic. Everything's kind of a symbol. We've had that philosophical discussion regarding languages and how important they are and how they can be interpreted, I guess, right? Well, here's another language lesson for us. Everything's symbolic in this sense, but this is non-numerically, not explicitly numeric, symbolic approach to something like this. Here you go. These two things are equal to one another. Get the reciprocal of both and you're there. So what happens is, so Q is this. Flip, you know, if two things are equal, the reciprocals are equal, and you got this. This is going to get us there, guys. This is the big one right here. What we did was, so we got that. Pretty big move for us. Let's just go. Let's put them in there. What we got to put in there. We discovered that the focal length is 2.5. P, they told us, and like I said, I got all of this in the notes, you guys. If somehow we get our signals crossed on this thing, let's just get it right. The object distance was 9 meters. The image distance, the object that we're going to find the image distance rather. The object distance was 9 meters. The focal length was 2.5. And here we go. Object distance, focal length. And there you go. It's going to get you there. Just going to be there that way. How's that? The bottom is going to be 6.5. Bottom is going to be 6.5. This times this is, okay, let's see what we got here. We got 9 times 2.5 should be 22.5. It seems to be the number we're getting all over the place a lot of times. All right. So, and it's going to be in meters. So let's see what we got here. We actually, like I said, I'm doing some of this in my mind right now, guys. Just make sure I can get it right for you. 4.5 and that, yeah, that's going to be fine. Actually, do the division into here. It's going to be more than 3, less than 4, between 3 and 4 right here when you actually do it. And what happens is you get 3.46. That is the image distance. Now remember, the object distance was 9. We knew it was 9. So from here, I got, you know, it's kind of in the back of my mind when I want to tinker with some of this stuff, what I want to do, what I want to not do. So this is the big one right here. We got this. This is the answer they wanted on that one. Let's keep talking. The magnification, there's a reason I set them up like this, right next to each other. The magnification is image height or object height, or the opposite of image distance over object distance. Well, wait a minute. Image distance, we just discovered that, is 3.46. Put a negative in front of it, that's the formula. The other one's 9. And then you go from there. M is going to be negative 3.46 divided by 9, which is going to be negative 0.3846. So there we go. That was B. This is C. Finding the magnification. For D, because Q is greater than 0, it is a real image. It is on the same side of the mirror. It is on the same side of the mirror as the object. The image is on the same side of the mirror as the object is. Therefore, Q is greater than 0. The image is real. And they give a good summary of this in the book, guys. I need people to be looking at that as best you can. This is not the way I wanted to teach the stuff, guys. I wanted to have a month or two to talk to you about all of this in person, rather than try to cram in some major parts of the whole issue and then go that way. But we got what we got. So, and we're going to do good. We're going to be fine. So the image is real. That's D. You know, they talk about a magnification here. For some reason here, we got the magnification. I said this. They talk about whether it's inverted or not. The very fact for E, the fact that just a little good practice for us, guys. We got this. We got this. That's a negative magnification. Image is inverted. Because it's a negative magnification, you guys, the image is going to be inverted. Is that legible, or do I need to write that a little bit better? Is that okay? That inverted, that should be okay. Is that?
It's like getting close up here.
Might tape my finger here a little bit. I've been using it too much, I think. Is that okay? Is that okay, or you? I can do it. I do it again. No, okay. All right.
Yeah.
So that's 14. That's 14. Let's look at 19, you guys. I'm going to go from the key on some of this stuff as well, you guys. 19. A spherical mirror is to be used to form an image 5 times as tall as the object. Or a spherical mirror is to be used to form an image 5 times as tall as an object on a screen positioned 5 meters from the mirror. Should the type describe the type of mirror required? Where should the object be positioned relative to the mirror? Okay. Again, you have all of this, guys. Forgive me for sounding like the broken record that I always sound like, but you have all of this on canvas. So we're going to work on it. I know what you're going through. I'm trying to make this as reasonable as possible. People need to be looking at the videos. They need to be studying the problems. And I am aware of what you are going through. So it's not, you know, it's gonna work. There's no set curve on this thing. The curve gets set by you guys. And the performance will determine where we are. I believe that'll be a good thing. So they're saying, how are you going to do this? 5 times the size, the whole thing. From the answer key, ladies and gentlemen, I'm quoting an image. From the answer key, I'm quoting. An image formed on a screen is a real image. Thus, the mirror must be concave. Since of mirrors, only concave mirrors can form real images of real objects. That's A. That's the answer to A. Again, I'll say, it's from, an image formed on a screen is a real image. Thus, the mirror must be concave. Since of mirrors, only concave mirrors can form real images of real objects. So that was A. B, they're talking about things we can solve given what we know now. Okay, so look at key on this one, or look at the key I gave you as I looked at their key to get a strong answer too. So they helped me tremendously. Look at key presented. B, remember a lot of stuff. H prime over H equals negative Q over P. What does that mean? Well, I mean, like I said, I don't want to belabor the point, guys. Image distance over object. This is better notation than this, but if you can remember, Q is image distance, P is object distance. The negative you just throw on there because that's part of the derivation that was obtained. Magnified real images formed by concave mirrors are inverted. So this is important, also something we quote. So when you look at something like this, you guys, forgive me, I did not tell you what problem we were doing. Problem 19. At least I didn't write it down. Magnified real images formed by concave mirrors are inverted. So M is less than 0. So what do we got here, guys? We got M, so we're the whole process here. M is less than 0. It's inverted, so it's going to be a negative magnification, and that's equal to negative P, negative Q. Negative Q over P. The image is going to be found 5 meters away. Remember what they said now here, guys. Let me just try to let me not get too cavalier about this whole process. A spherical mirror is to be used to form an image 5 times as tall as an object on a screen positioned 5 meters from the mirror. If the screen is positioned 5 meters from the mirror, the image is going to be 5 meters from the mirror, you guys. So the image Q is going to be 5 meters. 5. You throw the negative out in front, because that's part of the equation that we got. Negative 5 is a magnification of negative 5. Let's see what else we can do here. And figure out what we got. So, and we got P right here. Where's the object got to be positioned for that to happen? Solve for P. Multiply by P on each side and divide by negative 5. So it's this. 1 meter in front of mirror. Meter in front of mirror. Also, the key tells us that, we talked about all this stuff, guys, how to actually find, I think at this point they're telling us to find the focal length. Well, they didn't really say that. I mean, describe the type of mirror required. It's going to be a concave mirror. Where should the object be positioned relative to the mirror? I think we're done. I mean, on that one. The interest here is they didn't really, for some reason, there was some extra thing I had done here. I'm not wondering why I even did it, but why not? I mean, we also remember they didn't really ask us beyond this, but just kind of a little added practice for what we're doing. We do remember this. This is very much bread and butter. Image distance, object distance, focal length. How do you solve for F? Well, you solve for F a lot of ways. If these guys are equal, if you get the reciprocal, you get the reciprocal of this guy, and then get the reciprocal of this guy. Be careful. Don't be flipping them individually. Find out what's going on under here. Under here, what happens, you got this, multiply this guy, this term, by a special one called Q over Q, multiply this one by a special one called P over P, and what you got is, you got Q plus P over PQ. Now the reciprocal of that, now we already did this, you know, forgive the repetition here, but repetition is the mother of learning sometimes. It's good to hear it again and again sometimes. You're coming out to here. This leaves it symbolically done, and we'll get you there. If you plug in all the appropriate stuff here, if this is 1 and this is 5, and this is 5 and this is 1, 5 and 1 is 6, 1 times 5 is 5, 5 over 6 is, you know, 0.8333 going on forever. For the record, that's the focal length. I don't even think they went in that direction, but like I said, if you put what you have solved, right, we said P is 1, Q is 5, 1 times 5 is 5, 1 and 5 is 6, 5 over 6, there you go, there's your focal length. Positive focal length, and everything we had said on that. So that is problem 19 for you, okay? Let's go to topic 24 and proceed from there.